Hello, my humans. Let's go ahead and make a video here. We got Mrs. Key. And let's see. We need to factor. Factor the left side of the equation, then solve to find the zeros. There are certain steps that would be a good idea to take. I'm going to try to go through them again. There are probably like 8 different videos of me doing this. Hopefully I do the same thing in each one. So make sure you pay attention. So I'm going to take the first thing I do is I look to see if there is a greatest common factor. There is not, so I don't need to take out a greatest common factor. So I go ahead and I multiply the first and the last, so negative 12m squared. And then I write down the middle term. The middle term is negative 4m. My goal here is to find numbers that multiply to negative 12 and add to 4. I'm just going to write down all the numbers that multiply to 12. Those ones multiply to 12. And I need to multiply to negative 12 and add to negative 4. So really what I want to look at is there a pair that has a difference of 4? That one has a difference of 4. If I make this negative, 2m minus 6m is negative 4m. 2m times negative 6m is negative 12m squared. So that is the key to what I want. I'm going to rewrite the initial equation. I'm not going to change the m squared or the 12 or the 0, but I'm going to rewrite 4m as 2m minus 6m. I'm then going to say, okay, what can I do with these two? You take out an m, you're left with m plus 2. If you want, you can say, all right, from these two, I want m plus 2, so what do I need to put in front? Well, I have a negative 12, so if I multiply by negative 6, that gets me negative 12. Let's double check. Negative 6 times m is negative 6m. Negative 6 times 2 is negative 12. Now, you're obligated. You have to. These are the same. So you go, woo! Because those are the same. And then you rewrite it as m plus 2, sorry, and then m minus 6. So that's the factored version, but we're not done yet. To finish, we have to write two equations. M plus 2 equals 0. So m is negative 2. Subtract 2 from both sides. M minus 6 is 0. So m equals 6. And those are your solutions. Same idea for this next one. I first look for a greatest common factor. Between 2, 21, and 40, I can't take anything other than a 1. So I'm going to take the first and the last and multiply those. So it's going to be 80x squared. And then I'm going to write down the middle term, negative 21x. Now I'm going to write down numbers that multiply to 80. 1 and 80, 2 and 40, 3 doesn't work, 4 works, 4 and 20, 5 works, 5 and 50, and I need 30 more, so 16. 6 doesn't work, 7 doesn't work, 8 works, 8 and 10. Which of these makes 21? Ooh. These ones make positive 21, but I need a negative 21. If I make those both negative, when I add, I get negative 21. And when I multiply, I get positive 80. So that's going to be what I need. So leave the 2x squared, leave the 40, leave the equal 0. Split the 21 into 5x, negative 5x, and negative 16x. Now you're going to GCF. So what is the greatest common factor of those? It's just x. You're left with 2x minus 5. If you want to assume that you're going to get 2x minus 5, here, that might help. So how do I get 40? I got to multiply by negative 8. Let's double check. Negative 8 times 2 is negative 16. Negative 8 times negative 5 is positive 40. So then I'm going to have, oh, those match. So I got to go, woo! So then I have 2x minus 5, 2x minus 5, x minus 8, and this is equal to 0. So that means I write 2x minus 5 equals 0. Add 5, divide by 2. You get 5 over 2, or 2.5. X minus 8 equals 0. Add 8, x equals 8. So we did it. You can check yourself by plugging those things in and seeing that you get 0 when you plug in. Next one here, we got table, identify domain, and range. So the domain is going to be, I'm going to put them in order because it makes me more comfortable. Negative 2, negative 1, 2, and 3. And then the range is going to be 1, 2, and 5. I don't have to double list 5. I can just write it once. And then function or not. So something's a function. If you want to draw the potatoes, feel free. -1, 2, -2, 5, 3, 5, and 2, 1. So something is a function if it has 2 pieces coming from over here going to 2 different numbers. It's okay. Sorry, I said that weird. If I had, let me do better. If I had -2 here, and that was going to either 5 or, say, 4, that would no longer be a function. Because if I put in -2, I'm not guaranteed to only get one number. In this case, I can put in any of those numbers, and I only get one answer back. Although when I put in -2 and 3, I get 5, that's okay. I can't put in the same number and get different answers. I can put in different numbers and get the same answer, that's okay. Don't get confused by that. So this is a function. For number 4, we're given a graph. So on a graph, you could do the vertical line test that Mr. Benkel and I have talked about in videos. If I draw vertical lines, if my vertical line hits the curve more than once, then I do not have a function. So for example, if this graph were to then come back over here and do this, that would not be a function. But since that doesn't happen, this is a function. And my explanation would be, you could say each input has only one output. You could say each vertical line only hits the curve in one place, that sort of thing. Given the function, find f of -3. So I'm given f of x. F of -3 means plug in -3. So 5 times -3 minus 2. 5 times -3 is -15 minus 2. -15 minus 2 is -17. Show us that work so we can see exactly what you are doing, so that if you make a slight mathematical error, you are still okay. This next one's different. We want to know when g of x is 5. So replace g of x with 5. So you have 5 equals 2x minus 13. This brings us back to earlier in class. By earlier, I mean like September, when we solved equations like this. So let's go ahead and add 13 to both sides. So you're going to get 18. And then let's divide by 2. So you're going to get 9. And that's the answer there. That's all there is. Let us know if you have questions, my friends.